Hi. So we're going to look at differentiation from first principles, which is a topic in A-level maths. So differentiation is just the process that we go through in order to find what's called the gradient function. And the gradient function is just an equation that we use to figure out what the gradient is. And gradient just means steepness. So it's all about trying to figure out how steep things are. And from first principles just means we're going from scratch. So we're not assuming any formula for differentiation. We're just going to use what we know about gradients. Um, so our question is, how steep is a hill at any given point? So we're imagining we're trying to walk up this thing up here. Um, and the question is it too steep for us to walk up? So we want to figure out what the gradient is at a given point, say around here. And we want to figure out to figure out if it's too steep or not. So now this is a bit tricky because it's not a straight line, but let's use a straight line to review what we know about gradients. So to figure out the gradient of a straight line, you normally just pick 2 points, and then you draw your little triangle, and then you find the change in x, or the horizontal distance between them, and then the change in y, or the rise, the vertical distance between them. And then the formula for the gradient is the change in y. This little triangle means delta, or change in y divided by change in x. So the higher that change in y is for every step that you go across, your step is like your change in x, the higher you move up in every step, the bigger your gradient's going to be. Okay, now this is a bit awkward to apply to a straight line. So normally in science, when you're told to like do rate of reaction things, you'd draw a tangent. So let's say this is our point that we're looking at, and I'm going to draw a line that hopefully has the same gradient as the gradient of the curve at this point. Once you've drawn your tangent, you can draw your triangle and do change in y divided by change in x, in the same way that we did this. But the problem with drawing tangents is it's not very accurate. We kind of want to, in maths, we want to be really accurate. So we want to kind of mathematically draw a tangent. So we're not really drawing a tangent, but we're going to define a tangent. So what do we know about this tangent? Well, it's one point on this tangent is this point. This is our point of interest. And I'm going to be really creative and call the x coordinate of this point x. Now, I'm going to say that this curve, this hill, has the equation y is f of x. So that just means the height y is some function of x. So it does normally in this case it's x squared, but I'm going to keep it general as f of x. So if the x coordinate is x, then that means the y coordinate is f of x. So we have one point on the tangent is going to be x, f of x. That's point of interest. Now, in order to define any line, we need 2 points. So we've got to think about what do we know about a second point on this tangent. Well, it's going to have to be on this line. Like, there's no good if our second point is up here, then our tangent would look like this, and that would be pointless. So it's got to be on the line. But what if it was back here? What would our tangent look like? That. Now that's not great, is it? So we want the second point to be as close to this first point as possible. So if it's here, then it's better. And then it's getting better. So you can see as this second point gets closer to this first point, the more accurate our tangent gets. So if it's here, it's like super duper close. It looks the line between them looks like the tangent line. So our second point's got to be on the line, and it's close. I'm going to say very close to the first point. Okay. So now I've got to translate these wordy things into maths. So I've said that the x-coordinate of this first point is x, and I'm going to say the second point, the super duper close point, let's say it's here. I know that's not really close, but so you can see it. I'm going to say it's x plus h, but I'm saying lim h tends to 0. This is a limit, and this tells you that h is actually really, really, really tiny, and h is basically just 0. So this second point that we've defined is x plus something that's really, really small. X plus 0, well, that's just x. So realistically, this second point is like on top of this first point, but they're kind of separate points as well. So yes, we're very close to the first point. That's good. We've got our x plus h. That's what makes it really close. What about on the line? Well, we've got to use the equation of the line here. So we said that if the x-coordinate is x, then the y-coordinate is f of x. Now the x-coordinate is h, is x plus h. So I just sub x plus h in here. So y is f of x plus h. So instead of f of x, instead of x, I'll just put x plus h. So our y-coordinate of our second point is x plus h. So the second point now is x plus h, f of x plus h. And now we've got 2 points, which is great. So we can define our line. So again, our second point is very, very close to the first point because the first point is x and the second point is x plus h, but h is super duper tiny, and I've told the maths that by saying lim h tends to 0, which means h is basically just 0. And I've also said that the second point is on the line because there's no use of our second point being out here. Like that's not going to be very accurate, is it? So our second point is on the line, and that's because I put it into this formula. So if the x-coordinate was x plus h, then the y-coordinate is f of x plus h. So now we've defined our 2 points on our tangent line, we can figure out what the gradient is. So we're going to use the formula that we used before, the change in y divided by change in x. So what's change in y? Well, our y-coordinates are in red, so our change in y is going to be f of x plus h minus f of x. And we're going to define that, but we're going to divide that by our change in h, by our change in x. So our change in x is going to be this one minus this one, x plus h minus x. And we can immediately see that these x's will cancel out. Now, we're talking about h's here, but we haven't said anything about what h is. We've got to tell the maths that the h is really small. Remember how the h has got to be really small, so our second point is super duper close to our first point. And we do that by saying lim h tends to 0 like this. And we put that in front of every line that's got an h in it. So lim h tends to 0 of f of x plus h minus f of x over h. Now this formula here that we've just made up, this is in the AQA in the Edexcel formula book. So actually when you're starting a question, you only have to start from this point. But I've just kind of shown you where this formula comes from. But we're gonna apply that now. So I didn't actually tell you what f of x was, I just said it's a function of x. But let's now say that f of x is x squared. That's between x. F of x is x squared. So lim h tends to 0. We're talking about f of x is x squared means whatever you put in, you square. So whatever I put in, x plus h, I square. So I square my x plus h. And then f of x is x squared, so minus x squared. and that over h doesn't change. So I keep writing my h tends to 0 because I've got to keep saying that my h is super tiny, and I expand this out. So I'm not going to go through that. X squared plus 2x h plus h squared minus x squared over h, and that simplifies to, we can see that the x squares cancel. We've got plus x squared minus x squared. So we've got 2xh plus h squared over h left. Running out of space. And then dividing through by h. 2xh divided by h. Well, the h is cancelled, so you've got 2x. And h squared divided by h. Well, that's just h. And then when you've kind of gotten rid of the fraction, you just think, right, let's sub in h is 0. So we've got 2x plus 0. And that's just 2x. So our final answer is 2x. So the derivative, which is this whole process we were differentiating the x squared, the derivative of x squared is 2x, and that's our answer. So this thing here, this 2x, this is our gradient function. This is the formula for the gradient at any given point. So we were asking what's the gradient at a given point on our y equals x squared curve. So so let's call the x coordinate of this thing 4. We just sub in that x is 4 into this gradient function. So that means the gradient, or the answer that we're looking for, is that it's 4 times 2. 4, I'm getting ahead of myself. 4 times 2, which is 8. So the gradient at that point is 8. So maybe if you can't climb up 8 meters for every 1 meter, then maybe that it's too high for you. Maybe the hill's a bit too steep, and that's it. So that's differentiation from first principles.